Okay, we'll get started. Hello, and welcome. I'm Lisa Walzer. I'm the co-chair along with Sloan Springer of the AIA New Jersey Small Firm Exchange. It's often shortened to AIA NJ SFX. We try to hold webinars like this one on a bi-monthly, every other month basis, alternating with Zoom meetings for discussions of topics of interest to small firms. We'd love you to join our committee and or be on our mailing list for finding out about events like this. To do so, please contact Christina Goldstein, our meetings and events manager. Our contact information will be in the chat. We also have a Slack channel. Information on how to join the Slack channel will also be posted. Our speakers tonight are Ben Horton and his son Zachary Horton, who will explain how to use scanning technology to produce as-built or existing conditions drawings. Ben is the principal of Ben Horton Architecture and Design, and he is on the Board of Trustees for the Newark Suburban section of the AIA. Zachary is a designer and the lead technologist of the firm. During the presentation, attendees will not be seen or heard by Ben and Zach, but may pose questions using the Q&A feature, which is typically found at the bottom of your computer screen. After the presentation, Sloan will pose these questions to the speakers. Attendees can continue to ask questions until we conclude by 9. Here's Ben and Zach.
Great, thank you, Lisa. We're going to start the presentation. Let me start sharing my screen here. All right, and let's start off with the PowerPoint. All right, here we go. I think we talked about having this seminar about the 3D scanners. As you know, you're going to get 1 learning unit HSU credit for this. We actually bought this scanner, 3D scanner, beginning of the year. When we've actually completed 26 projects so far. If you're like me, we do a lot of hand survey work. We go out there with a laser and sketch pad and measure out spaces, sketch out a space and take measurements, go back to the office, draft it out. And then sometimes we found we missed this information or that information, or some of our numbers don't add up. And, you go back to the site and you do it again. And you take a lot of photographs. When we learned about 3D scanners, we've been following it for several years. It hasn't quite gotten to the point where I felt comfortable investing in it, but recently we did start thinking about it more, and we decided to buy the Matterport Pro 3, which is the one you see in the middle here. The other types of scanners that are out there, some of our consultants use like the Leica or the Artec scanners, which are more robust scanner. They're much more expensive. You're talking like $90,000, $100,000 scanner versus Matterport 3, which I paid for when it was on sale. It's normally $8,000, but I bought it on sale for like $6,000 and change. So that's a huge difference, and that made it really little bit more affordable, but there's other associated costs with using the Matterport system, and I'll explain that as we move forward. But there's other variety of scanners that are available, but these are the type of scanners that are, I think, most commonly used by the professionals for scanning buildings, and they're pretty robust. And you can see the one in the middle that we have. It comes with a tripod, and the scanner kind of spins 3-dimensionally, scanning all the spaces around it. I'm going to have Zachary kind of walk you through a little later on the process that we go through to scan, but I just want to give you an overview of how the technology works. Once you buy the scanner, there's various platforms available that makes what's called twins, virtual twins. I think you may have heard of it. And I'll explain what that is a little bit more, but there's companies like Matterport, Giraffe 360, Hexagon, and 3D Vista, and there's a whole host of other websites. Giraffe 360, I'd say, is a little bit more popular in terms of the real estate world, where you could take a less robust 3D scanner and you could create that 3D tour, virtual tour that you see in real estate websites. A lot of times, if you go to realtor.com, you'll see certain houses or apartments that has the virtual twin that you can kind of walk through and see, walk the entire space. That's hosted by companies like Draft 360. Matterport actually does the same thing too. They host a twin, and we'll show you an example of that. Hexagon is, I think, more industrial grade type of stuff where they have scanners that are, for scanning minutia details of equipment and things like that, as well as they have scanners, obviously, you could use for scanning buildings. I found their services for architecture seem to be a little less comprehensive on their website. So I never really investigated too much with those guys. 3D Vista, they're one of the many companies that actually takes 3D scans, that takes a cloud file and converts them into a virtual tour that you could actually have on your computer. And you could actually walk through using their software through the space like a virtual twin of your building. But they don't have a hosting website where you can kind of have a cloud file, like you could go to realtor.com and be able to go walk through the space on your own. You'd have to find some sort of hosting website to do that. This is an example of a actual like 3D scan product. You see on top, there's a photograph of the space. This is just a screenshot, when you're on your computer, looking at the twin of your space. Down below is more like a dollhouse view or an axonometric view, looking at the entire floor plan. So that they're both the same file that you're looking at. One's you're looking at kind of the aerial view of it. The other one's a zoomed in view of the space, but they're one and the same file that you're looking at. So from a design perspective, you got the ability to enhance your as-built documentation, looking at the conditions. This helps you, I think, be more accurate and sort of photograph or scan things that are that you may not necessarily see whenever you're walking the site and you're taking photographs. When you take photographs, you're just taking hundreds of photographs, but it's hard to organize those in a way it's stitched together. Where if you have a 3D virtual twin, you could just walk the space once you're back at your office and look at everything. Turn your head up, look at the ceiling, turn your head sideways. You could see little details, and we'll show you again the examples of that. So you can imagine how that's going to help you, minimize your having to go back to the site to see what you missed. During construction, if you imagine you could scan the space pre, post, mid construction, you can see this is before and after image. You could almost imagine all the different benefits that you can have. It's almost like having a as-built of your three-dimensional as-built of your space. Here's a rough-in as-built, and then when you finish and close things up, where the ducts ran and things like that before you even, and you could even tell where you put the wires, the rough-in plumbing. Everything could be scanned if you want to take that extra step, and then have that available as an as-built. I think that's kind of the quick overview of the technology, which I think is basic. It's a 3D scanner. There's all these benefits that you can have, for as-built as well as design phase, construction phase, post-construction phase. There's those benefits, and I think if you think more about it, there's a lot of benefits you can gain from that. But I think right today we want to spend the time kind of going into sort of showing you what a twin looks like, what a cloud file looks like, and the steps that we take to take that scan, bring it to the office, and go through that steps in making it into an as-built floor plan. What you're seeing again is on the top left corner of the image is a virtual twin, kind of the dollhouse view. On the right is an actual cloud file that's been imported to a software where you can review cloud files for drafting purposes. Most commonly used software for bringing the cloud file and drafting and tracing out the building plan is Revit and SketchUp. Our office, we use SketchUp. We find that to be a little bit more easier to train people on. So we've been exclusively using SketchUp. So we're going to focus on how we import it into SketchUp and then go through the process of drafting. Now, some of you who use Revit, I've used Revit before too. It's a three-dimensional tool, so it works the same way. Just some of the little nuances of the tools you use in SketchUp, just slightly different in Revit, but the concept is the same. So we'll show you how to do that. And then as you work with the cloud file, you'll see that there's a method of taking measurements, because a cloud file is just a three-dimensional scan with hundreds, thousands of points representing a wall, all your ceiling elements. So you could take some really accurate measurements for things, after you can come back from your site visit. So that's one of the interesting benefits. And then once we draft it out, we typically import that file into AutoCAD and format it for our office standards to create a nice set of floor plans. So like we're going to walk you through, kind of talk about 3 different projects we worked on. This is a 80,000 square foot office building. It's a 4-story office building. So if you can imagine how long it would take you to hand sketch out that entire space and create an as-built floor plan out of that. So that's something we're going to show you. Now, here's an example of this is the virtual twin. And this is the final floor plan we generated, one of the typical floor plans. And then we're going to kind of show you a house. This is a 3-story house that's about 4,600 square foot. It's got 3 levels. This one was interesting because we scanned it, and then this company, Matterport, has a service where they convert that scan into a floor plan. And this is a set of floor plans that they generated, which is pretty darn good. It's not super accurate. They say it's accurate to the nearest inch. Sometimes that could be a problem, if you're dealing with a space with tight tolerances. But by and large, it worked for this project. So we did order what's called a schematic plan service that they provide. And believe it or not, each one of these floor plans costs about $15 a piece to order. So it's very cost effective. Another project is a 2-story office building. This is 5,600 square foot. This one is a good example because the floor plan, this is something that I found interesting about the 3D scanning. If you look at this floor plan, these walls over here are actually skewed. It's from this corner at the bottom left corner to the top left corner. It's off by several inches. Sometimes, if a wall is off by a fraction of an inch, you kind of represent it straight when you're surveying that. I don't even know if you would have noticed this unless you took a lot of measurements in this room, that this wall was askewed and this wall was askewed. It's just the way it got built. And if you were working with, an existing conditions plan and you didn't know that that was askewed, you're going to probably be scratching your head after you came back from your office, took some measurements, and you didn't take all the measurements. You literally would have to measure every single surface to figure out that these walls were askew. So this is a good example. The other thing that was interesting about this building was it had portions of the wall that was a concrete block and sections of the wall that was framed out with stud framing. And sections of the wall, maybe they just glued a layer of sheetrock. And because of the scan, we were able to distinguish where those differences were. And we were able to find out things like this wall was actually thicker, stud with a little bit of chase wall here. This was a thicker stud compared to normal wall. And, we were able to pick up little nuances like these little bumps everywhere. Sometimes you might have missed that if you were scanning. Hand measuring things. So that's an interesting project to look at. So with that said, I'm going to hand it off to Zach. And I think we're going to have Zach kind of first take us through, can you escape that? Maybe take us through the first, show us the twin. I think twin is a good place to start. So let's start with the 80 Cottontail. So this is what we refer to as a virtual twin. This is a 3D scanned, and it's a virtual walkthrough. Why don't we walk around the space a little bit? And as you walk around, look up. Could you look up? See all these ceiling details there? You can see all the details. Look down, you can see all the materials. If you do a good scan job, you could literally capture almost every little nooks and cranny. Keep on walking around. Yeah. So as you can see, we took multiple scans throughout the space so that you even go into that closet there. So you can see as you look around, we captured every little detail. You can see, and so you can imagine once you go out and go back to that kitchen area. You could tell looking at that window, look at the curved ceiling details, right? Imagine if you had to try to figure out how to measure that while you're on site. Look, there's these soffit details, window pockets. You can see the baseboards in certain locations. All those little things that it'd be almost impossible to pick up all those details if you were, hand measuring those, unless you took an extraordinary amount of time. And then why don't you do the show us the kind of the dollhouse view. So this is the same model. You want to explain that new feature that they added about the furniture?
Yeah, so sometimes the spaces we go to are pretty cluttered. So let's see, this floor here, the entire room was filled with boxes, which makes it hard to sort of
zoom in,
see what's going on in there sometimes. One of the tools Matterport is currently testing is a tool to hide the furniture. So if you toggle this right here, you can see it cleared out all of the boxes in these rooms, which gives us a clearer view of the layout.
Yeah, so this twin, and then why don't you zoom in and go into one of those rooms now? Yeah, it actually got rid of the furniture, right? Yeah, there's, why don't you, could you turn the furniture back on now? Yeah, it's like magic. All that clutter. Why don't you go to one of these? Yeah, see all the clutter in that room? All right, there's that room. Let's take the yeah, it's like what's that commercial where they make all the garbage disappear? Yeah, you just point to it and it disappears, and this is what it's doing, and this is, I mean, just technology at its best, I think. Yeah. So like you can see, like this is like a 4-story building. We scanned all 4 floors. It stacks it, so you're able to measure the floor to floor height pretty accurately because it 3-dimensionally scans it. And we scan the stairway pretty in detail so that 3-dimensional measurement is accurate as well. So you could get pretty decent floor to floor heights. Can you go in and again, when you walk the space, you saw the ceiling, so you could actually flip this and just look at this the ceiling layout also. So we use it to also create reflected ceiling plan as well. But you can see the stairwells. You have to why don't you talk about like the process of scanning and what you do to get an accurate scan and some of the nuances that you should be aware of?
Yeah, so when you're scanning the space, it's generally it's important to pay attention to the since it's scanning in all directions, you have to pay attention to what's above you and what the camera can see. So when we're trying to capture this, if we're trying to figure out how deep these cove lights are, you have to make sure the camera is positioned far enough back around here to,
Capture all the surfaces.
yeah, capture that back surface, the ceiling, and these and the doorways have to sorry.
Yeah, you have to actually go into the doorways and set the scanner up in multiple positions. So, you could capture all sides of the door. If you want to get that door jam accurately, you got to scan both inside the door and outside the door. You don't have to if you were doing just a virtual twin, let's say just for quick touring purposes. So a lot of times realtors, they'll go into a room, maybe set up the camera in the middle of the room and do one scan. And that's enough for people to be able to look around, see what the room looks like. But for architecture, you have to kind of be able to capture all the little dimensions. So if you look at that column bump out, if you only scan one side of it, you won't be able to see what's happening on the other side. And, a lot of times if you measure something on one side of the column, oh, that's a good detail. Go back. Yeah, like right there. Yeah. Look. So if you look at this detail right here, you see that there's a wall that steps back here. Plus you got that column bump out, and on the other side of the wall, there's another column bump out over here. And being able to get all those measurements, you just need to be able to scan all sides of this column, not just this one side. So you can see we placed the scanner here, placed the scanner here. All those extra steps really help to get the three-dimensional aspects of the scan, because the scanner's sensing everything around you three-dimensionally, but if it has a cutoff angle, it's not going to be able to scan that. So you want to make sure you get enough scans to do that, right?
Yeah.
Yeah, so you go through and do the scan. Once you do the top-down view now, so if you look at the floor plan, you can see how many scans do you think you did in each one of these bigger rooms?
In these bigger rooms,
Yeah.
I took about, I think 8 for this one, since we had all those ceiling details in here that we had to be mindful of.
Yeah, so you went around the perimeter of the room to capture all those three-dimensional aspects of the exterior wall, right?
Yeah.
And you took those extra steps just so you could capture those extra details, right?
Yeah, so you have to position the camera to be able to capture this pocket in here.
Hey, could you do that magic of turning off the furniture? I want to see what it looks like in here.
Yeah.
Ooh, got rid of some of the walls too. Yeah, so some of the stud walls disappear, looks like, but that's pretty cool. Yeah, so some of these bigger rooms, to capture all those details, like one side of the mullion to the other side of that mullion, because you were able to scan both sides of that mullion, we could actually get a cloud file that shows you exact measurement of that mullion, right?
Yeah.
Yeah. I hope you guys understand that, to get that mullion, instead of having to measure every single one of those mullion, because you scan both sides of that mullion, now you have a three-dimensional scan of that mullion that when you convert this to a cloud file, you could actually go in there in your software and actually measure the dimension of that mullion. And you could actually get an accurate measurement of the height of these mullions, the window heights and things like that. The twin model is actually good because, like, with this virtual twin, you could actually do some measurement as well, right? Could you show that feature here? So you do the measurement tool, and it gives you some basic measurements, but actually you could actually measure from one point to the other to get an approximate measurement. Now, these measuring tools, I found out it kind of rounds off a little bit. So it gives you a good general sort of dimension. So approximately the windowsill is like, you might be able to say these are like 4 foot 6 inches wide. you know, from mullion to mullion. But they do round off on this this part. But the cloud file, you could actually it's accurate to almost like a 16th to 1/32 of an inch. So on the cloud file, it's much more accurate. Whereas in the twin, this is just giving you good estimated dimension rounded to the nearest inch or so. So this is an interesting tool to have. Okay, so why don't we go back to the plan view? All right, so you can see the benefit when you do these scans. You think each one of these scans, can you tell them how long it takes?
Each scan only takes about 15 seconds, excluding the time it takes to move it around. I found that working in a team helped a bit because you can have one person just moving the camera around while the other person keeps out of the way and starts the scans.
Mm-hmm. Yeah, so on a larger job, I mean, you could do it with one person. Sometimes we've been doing it with two people just to test it out, doing it both ways. But this project was 20,000 foot floor plate times 4, 80,000 square foot. And how long did it take you to scan the whole thing?
3 days.
3 days of scanning. I think comparative to what it would have taken if we were to hand measure everything and sketch everything out, on top of the fact that we probably wouldn't have been as accurate. You know, my guesstimate is that it would have probably taken us at least over a week to field measure, field sketch, and measure out everything. And most times, I think, you know, building this size, we would have gone back a lot of times because we would have missed a lot of things. So I think there's some benefits there. And you know, like I said, the twin is great because you could actually provide this link to a website. It's like a hosted website that's on the cloud, so you could provide that link to your client, and then your client could kind of walk through the space themselves and look at things. The contractors could look at things too, like an as-built condition when they're bidding on a project, and look at what's there, as opposed to having to go to the site itself. So I think as we progress, people are going to see more and more benefits to using these twins. Now, why don't we jump from this one? I'll give them an example of the house, the driftwood house. Now, go ahead. So this is a 3-story house. And again, you're looking at the dollhouse view of it, but why don't we start from the street and kind of walk us through the house real quick? Yeah. I'm impressed by the resolution of these images. It's all very high res. And it's amazing that this scanner is picking up everything 3-dimensionally. You can see every little light fixture, every nooks and cranny. And again, if you do enough detailed scans, you'll be able to pick up more of the 3-dimensional features of the house.
Normally 3D scanners also have trouble with these mirrors, since it ends up perceiving the space to be a lot larger than what it is. So the thing that's also helpful with Matterport is they have a tool that lets you mark the locations of these mirrors, and that helps a lot with the accuracy of the scans.
So all those circles are scan points, right?
Yep. It's a bit challenging to yeah, it was hard to get the scanner to fit on these stairs.
What did you tell me about doorways? Like a lot of times when you scan, you want to scan with the doors open so you could get the wall thicknesses too?
Yeah. So when we scan at yeah, one of the scanning practices is to scan on both sides of the door. So that way you can get the location of these edges of the door And then when you get this combined with the opposite sides, that allows you get the thickness of the walls
more
here.
accurately, right?
Yep. These closets, you can figure out the size of the gap that's between them fairly quickly.
Yeah, when we field survey, we always measure the jam dimensions on both sides of the doorway. So make sure the chase walls, if there's any chase wall, we could find those. A lot of times it's hard to tell if there's a chase or not. But I think if you do a good scan, it picks up all those things that you didn't really notice when you were at the site. Mhm. All right, so this is obviously like bay windows, things like that, taking measurement, all the measurements you need to get those angles correctly. We scan it, walk away, and we got it. I think there's definitely a lot of benefits to that. Why don't we go to now let's go to the cloud file. So since we looked at 80 Cottontail, which was that 80,000 square foot office building, we're going to show you what the cloud file looks like. And can you explain the process after you scan? What do you do with the file, and then how do you get it into the cloud?
Yeah. Okay. So when we get the cloud file from Matterport, comes in a format called XYZ.
Let's see, they show them the folder.
Okay. This one. So yeah, so it comes in as this XYZ file, which is contains all of the 3D data. But since that doesn't natively work with SketchUp, we have to convert it to this E57 E57 file before we can import it.
Yeah, but that allows you to bring it into SketchUp. But basically, I think the step is once you scanned everything, the scanner, you bring it to the office, you connect to the internet, or you scan it onto your app on your phone, right?
So like we pair a device with the camera. The camera sends the 3D data to the device, and then from the device we can upload it to Matterport.
Yeah, so you could either use a smartphone or use an iPad. We've done both. We loaded the app on our smartphone and we loaded it on our iPad, and we did it on both. One of the things that you found out early on was take an extra battery, right?
Yeah, it drained battery pretty fast.
Yeah, so you're scanning with your phone, and if it takes more than a couple hours, you're going to drain your phone battery pretty quickly. So it's good to take extra backup battery to charge up your iPad. That's a good tip. But once you scanned it and you have it on your device, your phone, the app is on your phone or your iPad, that connects directly to the internet. We usually, iPad is wireless. We don't have a cellular iPad. We have a regular wireless iPad. So once we bring it back to the office, we upload it onto their website, and we order the cloud file. So they go through that process of taking the scan and they convert it to this cloud file, and they email it to you, or they actually put it in your account, and you could open up the account. Can you go to the account file folder?
Account file?
Yeah, show them what our account folder looks like. Yeah, so we have an account set up with Matterport. It's a subscription service. Depending on how many projects you guys anticipate doing, you do the subscription. And it allows you to store a certain number of projects. So this is our account website. And once you go to the project folders where all the projects are of different spaces, go to the root.
No project folder?
Yeah, go to our folder with all the spaces.
Have to go to,
Just go matterport.com.
this has the login on it. Just a bit fast.
That's mine.
Yep. Okay.
So once you go onto Matterport website, it stores all your project scans on the cloud, so you can access it anywhere. This is the our account. You can see all these different spaces that we scanned. This is loading up. So if you scroll down, you can see these are all the various projects. There's about 26 projects we did so far. And you come to this website, once you scanned it, it puts it into your account. And then if you order that, what they call the Matter Pack, the cloud service, where they convert the file to a cloud file, you come here and you'll be able to download it onto your computer. So once you download it, then you could import that file into, either Revit or SketchUp. In our case, it's SketchUp. That Matter Pack currently costs, for each scan to convert it to a cloud file, costs about $59, which, it's a fee that you have to pay. And I think that's the reason why they were able to keep the price of the camera down, because they're hoping to make up the revenue, I guess, with the services that they provide. And I think it's a reasonable price point, $60 to get the cloud file. Considering all the labor savings that we're seeing. So now you scanned it, you upload it into the cloud, they converted the file for you, put it into your account. How long does that process take?
After uploading it, it usually takes depending on the size of the scan, it can take about like at the shortest, like 15 minutes.
So once you upload it, they make the Matter. Once you ordered the Matter Pack, how long does it take for them to convert it and give it to you?
That takes 30 minutes, but for the smaller ones, for the 80 Cottontail, which was a massive scan, that one took at least 4 hours, I think.
Yeah, so a lot of times you come after you're done scanning, you order the Matter Pack, let them process it. Next day when you come to the office, it's usually there ready for you to go, right?
Yeah.
And then this is the cloud file that you get, that you imported into SketchUp. We're not going to do that right now, because once you open up SketchUp, you insert the cloud file, and that process takes about 5 minutes sometimes, right? Depending on the file size.
Yeah, usually shorter.
Yeah, but this one was a pretty big one, so we're not going to do that for you, because we'll all sit here for 5 minutes waiting for it to load up. But he already loaded this up, the entire floor plan. But you could see this is kind of what it looks like in SketchUp. You got all the levels, and obviously if you're familiar working with SketchUp or Revit, you could crop it, isolate each of the floors, and you're able to take measurements. Once you're looking at the kind of the overall view, everything looks kind of fuzzy. One of the things I got to tell you, like, people had a hard time sort of getting used to is once you insert the cloud file, how do you work with it? Just visually, it's a little different. It's fuzzy. It's not sharp like the Twin, but if you zoom in, why don't you show how like you could zoom in and snap to the points?
So, one of the things you can do is create a clipping box, which will let you trim down the scan so that way you can get to the floor that you're focused on. So from here we can cut out the ceiling there to see inside the 4th floor and go down until we get to here. And
the line work that you're working on, that was the 4th floor.
Yeah, this is the line work for the 4th floor. But this out of the way. Where that went. Okay.
Why don't you zoom in on the cloud file so people can see what it looks like a little bit more input.
Yeah.
Yeah. So it looks fuzzy at times, but if you kind of wait, it generates and gets a little sharper. But you could see there's thousands of cloud points, that's why they call it the cloud file. Each wall, like you have thousands and thousands of points that you could snap to. And the SketchUp recognizes those points and it could lock into these points. Like show them how you would draw like a line to represent a wall and then draw another line to that's perpendicular to it.
Yeah. So can start at a point, lock the line to an axis.
This floor plan doesn't seem to line up though.
Yeah, I don't know where first floor went.
I think you cropped it out and raised it. You used the just draw a new line there. Yeah.
So can lock to the axis, drag along the wall, because if you're looking at this the indicator there, when you hit the wall, it stops and snaps to it. So we can draw from there, snap to this wall, and that locates the corner of the room. And there we can go, from there we can go here, here, here.
Yeah,
And now we have that room boxed out.
I think you just saw a quick demo how the software is able to recognize those cloud points, so you could use a procedure to snap to each one of those walls so that it's perpendicular to each other. And sometimes the wall might be off by a fraction of an inch, but in general, you would, as architects, we would represent that as a straight wall. And then once you have that wall drawn for that first wall, you could offset that line, the relative thickness of that wall, right? So why don't you show them how you offset that?
Yep. So take this, use the offset tool, and that'll give us the thickness of this wall, which,
We got to snap to it now.
yep, that's about 6.5 inches.
Mm-hmm.
And we can start drawing the next room.
Yeah, so that's something that you make a value decision on, right? When you get the measurement, it might tell you it's like fraction of an inch off of 6 inches, so you round it up to 6 inches. Or if you get a wall that's 5 inches, it might be 4 and something, but you use judgment to say that wall is typically nominally 5 inches, so you'd offset it 5 inches or so, right?
Yeah.
We had cases where we've seen doing this method, you have certain walls where it's a lot thicker because there's a chase, right? And you're able to measure both, snap to both sides of that chase wall so you could get the accurate dimension of that chase, right?
Yeah.
Again, it's like you do have to make value decisions on where, how thick to make that wall. And then now you get this situation like this where you got some curved or segmented wall, right?
Yeah. And it does give you it does give you an idea of like how you can approximate it. So using the arc tool, we can go here to here. Increasing a bit. That gives you a decent approximation of the wall curve.
Yeah, he's going on the fly a little bit quick for you guys, but you could actually take a little bit more time and get that a little bit more accurate.
Yeah.
But I think when you show a planimetric view now, what you just drafted.
Yep.
The street plan view, because you're looking at things three-dimensionally. And then you can see it when you look at it flat planimetrically, yeah, how things kind of line up a little bit better there. And do you have why don't you go jump to the Oasis project cloud file?
Yep.
Now this one was that 5,000 square foot building. Now you can see all the walls were traced out, but if you look at that wall over here, showing the wall that's askewed. You know, see that wall? Point to it. Yeah, that one here. Like if you were in the field measuring these things, you wouldn't recognize that was actually askewed, but you can see right now that's off from one end of the lower left corner of that wall to the upper part of that wall. That's like off by several inches. But why don't you draw that line and show what the distance is there?
That would be about 5 inches off.
Yeah, so you can see that wall was off plumb by 5 inches, you know, orthogonal to that bottom wall. And then interesting thing about this building was that you had certain cases where the walls were furred out a lot more along the perimeter. Certain walls where the walls were actually bare concrete. And the nuances of all those dimensions where we were able to capture that by looking at the virtual twin, looking at this cloud file. And we were able to recognize all those little differences in the wall thicknesses. You can see here, why don't you show them that thick wall where the bathroom is here? Yeah. You can see how that bathroom wall was a lot thicker on the one side, which was kind of strange. You'd always think that the wall that the toilet is up against would be thicker, but in this case, it wasn't built that way. But we were able to find all these chases where chases were built. You can see all those little dimensions there, like where the column is, all the measurements you would have to take to just measure all these little differences around this column here, right? The scan was able to capture that. And yeah, once you trace out the walls like this, right, and locate all the basic things, the doorways, I think you do the doors on AutoCAD, not on the Revit, right?
Yeah,
On SketchUp.
normally I make the openings in here.
Mhm.
Um,
So you could get the jam locations, right?
yeah, so like and measure that out.
Mhm. Yeah, we try to locate all the door opening locations here because we get the jams more accurate. And then once we bring it into AutoCAD, then we'll insert all the doors. What
Yeah.
about the windows? How do you handle the windows?
Similar way, we can raise this box up a bit. So in a similar way, we can mark out the opening of the window.
Mhm. Yeah, so he just located that window opening, snapping to those surfaces using this cloud file. The other thing is interesting is because you scan both the inside and outside of the wall, you could get accurate wall thicknesses too, right?
Yeah.
The exterior walls. So that's been helpful.
Here the wall is actually
Thinner, yeah. So we're just showing you a different stage of the drafting. Obviously, all this little nooks and crannies, where the walls are thinner, thicker, we draft that all out. Why don't you go to the twin of this one so they can kind of see that room? So this is the twin of that building that you just saw the cloud file for. So it's a 2-story building. You can see that exterior wall there. Going through that door, you can see that doorway was once a garage door that they infilled with a stud wall and stuccoed it. And so you can see all the little dimensional differences there. So inside of that exterior wall was CMU. And let's go to the right of the space, yeah. And keep going all the way to the opposite side of the building. You can see all of a sudden you see the exterior wall was wrapped with gypboard there. And then if you go to the inside of that, underneath that stairwell, you can see there now it's bare concrete block. Now, because you scanned all this on your cloud file, you could actually measure those thicknesses, you know, how much of that fur out wall was. Yeah, you can see that all those dimensions that you see, you could actually measure on your cloud file.
Yeah. And we caught all of this in all of these details in just 3 scans.
Yeah. Yeah. The other thing that's interesting that we haven't done yet is you see all those meters. If there was an electric box, meters, you could actually notate this twin, indicating what those are. You know, engineers could add notes about like the panel size, you know, if it was electric panel, you know, all the details for it. We haven't quite used that yet, but I think it's coming. Yeah. Mm-hmm. So now, once we sort of gone through that, a lot of times we'll look at the twin like this and look at the cloud file at the same time. So having 2 screen, I think, is helpful when you're working on this. So you'll work on this in conjunction with the show the cloud file. Yeah. Well, yeah, nowadays I think all the workstations we have at the office has 2 big monitors. So you try to work on, you can look at 2 things at once. On one monitor, you're looking at the twin, another monitor, you're looking at that cloud file. You can see that's the same stairwell you're looking at there. But you could literally get into that cloud file and measure all those little dimensions. Once you zoom in and look at that handrail. So you can measure those dimensions, little dimensions there.
Yeah, sorry, I'm not much of a speaker.
Yeah, I think that the cloud files you can see, you could go in and you could snap to surfaces to get dimensions. You know, you could actually measure the exact dimension of that tread. You can measure the riser heights, you know. I think the first job you did, it took you a little bit longer, but I think by the time we did our 3rd job, you were flying through this pretty quickly.
Yeah.
Right. It takes a little learning curve, zooming around with this cloud file. It could be disorienting at first, but I think, once you get used to it, it seems to be quite easy, right? And you've been training everybody in the office with that too, right?
Yeah.
What do you think the learning curve is for people?
I think the biggest learning curve is probably whether you're familiar with SketchUp in the first place, I think.
Yeah.
Because once people understood how to maneuver with the SketchUp camera and snap the lines properly, I think they were managing to do it in about, I think Victor got this entire floor done in like hour or two.
Yeah, because like for example, Kira, she never did SketchUp before, right?
Right.
She never did AutoCAD before.
Right.
You had her learn to do the SketchUp, and then once she scanned it, she brought it into the cloud file and started sketching it within 2 days, like she was up and running, right?
Right.
Yeah, so it's the learning curve is very short, I think, with this, especially with the I find with the younger generation, they're so used to zooming around these virtual world and stuff. They play with these virtual games all the time, so zooming around SketchUp is almost intuitive, Kira she's never worked with SketchUp ever before, did AutoCAD, but she was able to jump in, open up SketchUp, and start preparing these as-built drawings pretty quickly. Now let's go to the actual floor plan that we drafted, final floor plan. Yep. So like, for example, like this is that small office building. We were able to draft out all the door locations, all the wall locations. You can see the angle walls here. Like this wall, you can see is skewed. So is this wall, normally if the wall was off a 1/16 of an inch, you're not going to show that skewed. You're going to just draw it straight. But these were so severely off, we did have to draw it because it would impact any renovation work you would do here. You could see how this wall was much thicker here. You could see how all these nooks and crannies around this column was identified. These chases were identified. This thick wall was picked up. This is something you might easily miss, the fact that this wall was the actual thicker wall rather than this one. The fact that the scan was detailed enough that this entire wall was concrete block, as you saw in the twin, but when you got to right here, there was an actual thin layer of chipboard here, 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 but then when it got to the back wall, it was a little bit thicker. They use a thicker furring strap. Over here, they actually put a full stud wall over here. So all those little nuances we were able to capture. Now, why don't we show the cottontail? Now this one, after they drafted it out, you could see all those building column locations. I mean, it made sense. We were able to sort of determine and guesstimate where the building structural columns were. I mean, it took some thought, right?
Yeah, for some of the other buildings, it's pretty hard. You have to think about you can sort of extrapolate where the column locations are based on the locations of these pillars around, or
the walls.
Yeah,
because you surveyed all those walls, and you could kind of guesstimate where the structural grid is. And some of them you could kind of tell by looking above the ceiling where they were located, but even the ones that were hidden, like this was a hidden column over here. This was somewhat hidden, but it was kind of, there was enough of a bump out over here that you could tell there was a column there, right? But I think once you sort of drafted everything out, you had to make educated guess where the columns might be located and determine this grid. Now, this is approximated, but I think it's pretty accurate, the spacing that we determined is is the structural grid. And the window mullion spacing was all very accurate too, right?
Yeah.
You were to get a sense of how the window mullions were spaced out based on the cloud file. Again, like that's something a lot of times we'll just spend hours drafting out, sketching and measuring at the field, right?
Yeah.
All right. So I think we just walked you through that whole process, going to the field, scanning, taking the file, uploading into Matterport cloud service. They convert it to a cloud file. You take that, download it into your computer, bring it up in SketchUp or Revit, and you draft out all the walls, door locations, and then you import it into AutoCAD, and then kind of give it the finishing touches with the final door locations and kind of identifying where the structural grids are, right?
Yeah.
Yeah. So I mean that's the whole process. I think that kind of concludes our presentation here. So we'll kind of open it up for questions. All right, we'll stop sharing.
That was great. I appreciate it. That was I love that you actually got into the weeds of, showing everybody how to do it, not just kind of the top down approach. So thank you so much. Let me pull up our questions here. All right, so the first question, this job of producing as-built belong to specialized firms doing this for a living. Why the change?
Oh, I don't think it's like specialized firm. I mean, as architects, we do as-builts all the time. I mean, especially smaller projects, we were out there like we'll go measure out offices, layouts. Some of the bigger projects, if you don't have the time, we'll usually hire out consultants to do it. But a lot of times we like to go look at the site anyway and take a lot of photographs to look at existing conditions, because sometimes your as-built consultants don't get everything either, and there's an art form to it too. But in majority of the cases, we survey our work as much as we can, and we just found that using this 3D scanner just expedited that process. We still use consultants, we especially doing these larger projects. We wanted to give it a shot, see what.
Yeah. It generally found that it's like saved us a lot of time, and consequently, because it's saving us time and work hours, it's making us a lot more efficient.
Yeah. I mean, if you budget similar sort of fee we would have done to account for the survey work, and we were able to do it better, and then have this extra sort of product, which is that virtual twin in the cloud file, we're able to make less mistakes and look at things that we maybe not have picked up, just taking photographs, so there's a lot of benefits to it.
So for the multi-story big building, how long did it take to scan all 4 levels? And I think you mentioned about 15 to 30 seconds per scan, but how long for the full thing? Is it 3 days? Maybe I missed.
Yeah, 3 days total. 3 days total. It took us about day to get. In a day, we got about a floor and a half. So that's about 30,000 some square feet in a day. Yeah.
Warehouse building is interesting too, right? Because it's a big open space, and so you think it'd be super easy, right?
Yeah, open spaces actually bring up some complications, because if the walls are like, if it's just like a sterile white space, sometimes the scanner will have problems aligning the scans.
But why don't you talk about time-wise that 40,000 square foot 3-story building, offices with lots of walls, it actually gives you a lot of surfaces to scan, and so the scan is actually better, right? Because it's able to sort of like understand what's next to each other, whereas an open warehouse space, it's a little difficult, because everything's spread out. So if you follow the exterior wall very carefully, it's good. But then that next column that's 50 foot away, it's a little tougher to accurately like pinpoint the dimension of that spacing of that 50-foot column unless you get that accurate perimeter measurement, right?
Right. Yeah. One of the things we just started using are these scan markers. So you place them around the space, and they're little they're pieces of paper with sort of like a QR codes on them, and the scanner can use those codes to figure out the orientation of the walls, the distance between the walls, and it generally makes the process a lot more consistent and a lot faster.
Yeah, so that's, but I think so. Like, let's compare that to the house that 4,600 square foot house. How long did that take for you to scan everything?
That took an hour or two.
Yeah.
Yeah.
Yeah. So literally to scan the whole house, it took you like under 2 hours.
Right.
Yeah, that include the inside and the outside for three levels, right?
Mm-hmm.
And it looked like you really took a lot of detailed scans.
Yeah.
Yeah. So just compare that to how long it would take you to survey and measure up a whole house, right? You know, of course, there's that time that you'd have to draft things out back at the office, looking through your notes and figuring out, hey, did I get that measurement right? And you start drafting things out and you go, oh, wait a minute, things aren't adding up, right? Because you might have taken a mistaken measurement somewhere. And so you're trying to figure those things out. Whereas this kind of avoids all that, right?
Yeah.
Yeah. So there's definitely inherent benefit. Now, so you got 2 hours to scan, under 2 hours to scan that entire house, right? The drafting time, I think there's that drafting time where you have to import that cloud file to SketchUp, draft things out, and then bring into Photoshop, into AutoCAD, and then finish up with some extra little details. But in reality, I mean, like you've done like surveys where you hand measured and then converted to CAD file compared to this. Like, do you find that it's more drafting time doing the working with the CAD file?
I'd say less time drafting overall.
Yeah, but I think it's, to me, it seemed similar, like watching it from the outside, because I think in the beginning, you know, first when you're playing with the software, trying to, you know, work out all the bugs, there's that learning curve, you know, where I think you were drafting out the floor plans a little bit slower than you would normally do it. But then once you got into groove, you know, after a few projects, I think the actual drafting time itself is very similar to if you took a hand sketch and you're trying to draft it out and, you know, do it in AutoCAD, right?
Yeah.
Yeah, you know what I mean? So I think there's that, definitely that part of it seems to be similar, the actual translation of, you know, if you took hand measurements and then you put it on a CAD, you know, versus taking that cloud file and then snapping to each one of those wall surfaces and drafting it out. So there's that benefit. But the crazy thing is that you saw that house where we showed you the schematic plan. That was actually generated by Matterport. You order it and they'll generate that floor plan. They ask you to give them a day or so. Sometimes they'll do an expedited service, but we ordered it, and within I believe 2 days, we got all those floor plans back, and they were $15 for a floor plan, and it was good enough to work with. They'll charge you a little bit more to get a CAD file, but we have Illustrator, so we could take that PDF and reverse it and convert it to a CAD file, and then use that to, you know, put it to our standards and make it into a floor plan. That one, you know, again, things are, you know, if you look at the window details, it's not drawn the way we would do it. They also like kind of standardize the thicknesses of walls, but they do get fairly accurate. They do pick up the chase walls, but when things are off by an inch, sometimes that could be problematic. So we only use that for that house because the client only wanted to renovate a couple of the bathrooms. So having a reference floor plan, you know, and then we use that scan to the bathroom areas that we were working on, and the surrounding walls. We went to the cloud file to double check the dimensions and make sure those were accurate, more accurate than to the inch. You know, we got it accurate to, you know, like I said, like almost a 1/16 of an inch.
That's a perfect segue to the next question. There are errors in the as-built as done this way. What if these generate omissions and errors on drawings? Whose liability is that?
Hey, it's our liability no matter what. If you're hand drafting things, hand measuring things, you're going to make errors. This does minimize the errors. There's, you know, some translation that you do where you make educated. You have to still be rational and decide, okay, if this wall is off by, like, it's not perpendicular to this other wall and it's off just by a fraction of an inch, do you really draw it off, like off plumb, like 1/16 of an inch or 1/32 of an inch? No, you just draw it perpendicular. And when you're doing actual construction work, you know, there's a construction tolerance that you have to deal with, right? But I think the one thing that's impressive about the scan is that a lot of those chase walls we often miss when we hand measure things. We're able to pick up in the scan because you're three-dimensionally scanning all surfaces. So whenever you get that cloud file, all those hidden things that you might not have seen walking around the site, you know, think about it. You're going through a 20,000 square foot office space. There's so many things to measure. You're not going to capture everything. So I think if anything, it minimizes your liability.
Let's see. Kind of piggybacking off of that as well, to avoid the liability risks, we try to ask the owner for as-built. This way, the owner is responsible. Not a question, it's more a statement. But
I don't know. I don't buy that.
Yeah.
I mean, you're required to go field measure and make sure if there's any critical dimensions, you double check it, right? I mean, ultimately, you know, when we did hand measurements, you know, the client understood things are going to be off. You know, I mean, I had CAD files that I got from clients, and they said these are good. And I told clients, look, I don't care if you gave me CAD files. I need to go verify myself, right? I'd at least go to the site and double check some overall measurements. We had one project where a pretty reputable company developed these CAD files for this big building. It was a 130,000 foot building. And they had done an as-built drawing of it. We inherited the CAD files and we're working on a tenant interior fit out. The landlord gave us a CAD file and said, here, you work off of this. You don't have to do the as-built again. We said, well, with all due respect, we're going to go field verify at least, right? So we did. The wall was off by 4 feet, guys. They had to renegotiate the entire lease because the wall was off by 4 feet over a space that was about 200 foot deep. So that was a significant error, right? We had other buildings that we inherited CAD files where we went and and this is before the scanners, you know, we hand measure things, double check all these dimensions. You know, it was a big office building and we found most of the walls were off by up to 2 feet in certain cases. And a lot of the walls were off by several inches. Now, you know, I don't know about you, but that's liability, right? You know, you could tell them, well, I inherited the CAD file, you told me to work off of this, but because you didn't do your due diligence, you had these walls that were off by 2 feet. That really messes up your floor plan, right? I think that's more of a risk. So I've never would work on a project that way. But if the client did hire an as-built company, and we get the CAD file from the as-built company, we do tell the client, you know, you do understand that we're subject to the accuracy of their drawing, right? We just did one project last year. We have one company doing as-built floor plan for all the buildings. We got the CAD file, and you know, it's a 3-story building. We stack the CAD files because we take the XREF of all the floor plans and line it up. Well, when you line it up, the stairwell should line up, right? But in their as-built drawing, the stairwell didn't line up. The walls were all off. The wall that should have been straight vertically going all the way up didn't work. So we had to, we showed it, we showed the client, we tried to line things up, things were off. Overall, things kind of lined up, but there were several areas where things it didn't make sense, where things should have stacked three-dimensionally, didn't stack. And there were, supposedly a good as-built company. They're not the guy that I use, the guys I've used over the years, I told them those issues that I said, look, if you do a multi-story building, those vertical elements better stack up, but I had CAD files that didn't stack up. So I think as architects, we have to do our due diligence.
Let's see, what is the typical workflow for going from cloud file to 2D line work as shown?
Okay. So like after the process of like getting the cloud file from Matterport, we convert the XYZ to a usable format so that way we can import it into SketchUp. Generally the cloud doesn't like perfectly align with the origin as it was in the other in the examples that we've shown. So we have to move the cloud. There are tools to move the cloud over and rotate it so the walls are aligned with the axes.
Yeah, so if the building's orthogonal, he tries to take that three-dimensional cloud file and rotate it so that the reference wall, that's along the bottom of the plan is perfectly level. And then based on that, you start drafting out the plans. Most of the buildings are, orthogonal, you follow some sort of grid, and you establish that grid.
Yeah. Mm-hmm. Yeah. So, but once we get the cloud aligned, we can, we just draw straight lines from the origin to find the sort of X and Y of the corner. And then from there, we can start drawing out the rooms.
Yeah. Once you pick the corner, because you're like snapping to all these other surfaces, right?
Yeah.
Yeah. So, but I think that process is you upload the cloud file, you download the cloud file that you can import into Revit or SketchUp. One thing that I should note is that you can't just use regular SketchUp. You have to get SketchUp Studio.
Yeah.
Which has the add-ons that allows you to work with the cloud files.
Yep.
Yeah. Just in terms of pricing, your regular SketchUp annual cost is like $350 for subscription services, but SketchUp Studio is $700. I think it's like around $720 or something like that.
Yeah.
I can't remember.
Yeah, there are other tools that let you import the cloud, but like those also tend to cost money, like you end up paying like a separate subscription fee to SketchUp.
Yeah. So the SketchUp has that add-on that you have to get in order to be able to work with the cloud files. So, so you're talking about if you're doing an annual subscription like we do for SketchUp, it's $700 some per year. Again, we're doing this year. We did so far about 26 projects using that scanner. It more than paid for itself. Yeah.
So, once you draw out the lines for the floor plan, you can export it from SketchUp directly into AutoCAD as a drawing file. So, we import it from SketchUp to AutoCAD, and then we usually we set the lines to our standards.
Yeah,
just to clean it up.
Yeah, we don't do all the layering and all that stuff in SketchUp. We just use it to draw the physical plan layout. Even the doors, he'll just locate the door openings, window openings, basic mullion spacing, and then he'll finish it up in AutoCAD. We just find that that we use the tool for its benefit, because SketchUp is great looking at that three-dimensional object cloud file and snapping. Snapping to that wall, that wall, that wall. So you go boom, boom, boom. You snap, 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 draft out all the plan layout. And then The finishing stuff, like I said, putting the grid in, bubbles and all that stuff, we just do in AutoCAD because it's so fast.
Is the equipment simple to use?
Yeah, pretty simple. So like we have, as we talked about this before, we downloaded the app onto our company iPad, and you power on the camera, and it makes it, yeah, the process of connecting the iPad to the camera is pretty simple. And then from there, we're just moving the camera around and pressing the button to start the scans.
Yeah, I think like first project we did, I mean, I think we took extra time just setting up the tripod, thinking about it, talking about all these like procedural issues because we had no idea, you know, how to go about it. But after we did the first job, you know, we started thinking about, oh, we should have done this a little bit differently that way, you know, and
Yeah.
came up with better procedures. So there's definitely a little bit of a learning curve to be better, but first
Yeah.
job, first scan actually worked out pretty good, right?
Yeah, I think the skill floor to using it is very, very low. Like I figured out how to use it, how to set it up and use it within like 20 minutes, I think.
Yeah.
But improving it takes practice, I think.
I spent more time researching which platform to use, but at the end, honestly, for architects, there's no equivalent than Matterport, honestly, right now. There's other competitors that I read about that has similar sort of product, but it's glitchy still. You know, so I think until the space gets a little bit bigger, I don't think there's going to be too much of a competition other than Matterport. That Giraffe 360, I've seen a lot of the real estate agents use it because it's cheap and it's easy. They do the same thing though. Once you get the camera, you go scan a space. You could actually take your iPhone. They have a special thing where you could take the iPhone, scan your space with the iPhone, and you could create a virtual tour on Matterport with your iPhone. So you don't have to have a camera. The only thing is the iPhone, you're not going to get the accurate measurements like you can with their camera. That's the only difference. But a lot of the realtors, I find, they just take their phone, go around, scan the space using their phone, put it in the cloud, and they're even able to generate pretty rudimentary floor plans out of it too.
Are there any height restrictions for exterior documentation, like high-rise buildings?
There definitely are. I wouldn't be able to say what they are, but we can get when we're scanning the insides of warehouses, we can get from the floor to the like 40-some foot ceilings.
Yeah, so we were able to sort of measure that. The other thing that is helpful is if you're able to get on the roof. You scan the first floor and you get on the roof and scan it's on a 3-story building. We didn't do it, but we had a surveyor, professional do it. They scanned all the floors, basement, first, second, and third floor, and they got on the roof and scanned the roof. They scanned the exterior. So whenever you stitch all those scans together, now you got a good 3-dimensional map to get the heights more accurate.
Yeah, but well, I think specifically for this question about like the exterior, it is going to be a bit hard to get the a full like high-rise building using it. But for like 2 to 3 stories, I think you'll be fine.
Yeah, I mean, the 3D scanners were being talked about, like I remember, like over 10, 15 years ago, especially for historic preservation. Whenever the guys who were doing historic preservation, they really loved that 3D scanner because it would scan all these like ornamentations and stuff accurately, and they could import it into a 3D modeling software and get accurate replicas of historic details. Now, since then, way that technology has evolved is drone technology. If you see the drones, now they have that scanner attached to a drone, and the drone would just rise up vertically along a high rise and take a 3-dimensional scan of a high rise. And you're able to hire services right now using the drone technology combined with the scan. So that's a pretty cool thing. Obviously, we don't do a lot of high-rise work, so we haven't used that, but there is services available using that scanner.
I also don't know how to fly a drone, so
Yeah.
have to practice that before we pick that up.
You're a gamer. You'd be good at
What do
drones.
you mean? That's a bit.
Yeah. Well, like,
Okay.
I mean, it's you saw the movie like where they have these like futuristic movies where you have these drones flying around scanning a building, and it's able to like live like provide a three-dimensional map of a space, right? The military is using that right now, using that drone technology to map out caves and things like that. So it's gonna pretty soon we're gonna have that available. So instead of like me having Zach go around and scan and survey a whole building, he's gonna be able to get these robots to go out there and drones to scan the entire building. I think that's gonna happen right around the corner.
I think you're a bit off.
No, it's not. I
Yeah.
mean, pretty soon, like think about all those drones that are able to
Okay.
do all those formations, making those beautiful sculptural formations. It's only like we're just a step away from the AI being able to control a drone to go scan an entire building, on its own. Yeah, I think we're going to be close.
Going to have problems with the drones flying into glass windows like birds.
Yeah. When I say close, I don't mean it's going to
Yeah.
happen in 5 years, honestly.
Yeah.
I think, but I could see it in 10, 15 years. Yeah.
Yeah.
What are those rings when you were showing the interior scan?
Yeah. So Matterport depicts the in the Matterport's virtual twin, it shows the scan locations using those dots. So like in most of the rooms we had like
Yeah, each
Few of
dot,
them
like
around.
if you do a virtual tour, each dot represents where the scanner is. So if you walk from one space of the room to another space of the room, you can't just stop in middle of the room where those dots aren't located. It's going to take you from one dot to the other dot where the scanners were, because once you get to that spot, just like the scanners looking 360 degrees, you can stand on that spot, look 360 degrees, see everything that the scanner saw, right? So that's what those dots are. They're the scan spots.
on that note, yeah, I would recommend taking at least like 2 scans per room, because there is like a small blind spot above and below the camera.
Yeah.
So if you're trying to get every detail, you have to do at least 2.
Mm-hmm.
Camera can't see what you can't see.
Mm-hmm.
What about smartphone scanning apps like Polycam? These seem to eliminate the camera purchase.
They're just not as accurate in terms of getting the accurate measurements. That's it. But for realtors, it's fantastic, and a lot of realtors are doing that now.
Yeah, the Matterport app actually does allow like scanning using the device's camera, but yeah, it's subject to how your accuracy as a human, because you have to hold the camera at the right angles, you're rotating at the right amount, and so that introduces a lot of variance in each scan, and it's not quite to the level that we want to use.
Is there an AI tool application to blur the faces of people during the scans for privacy issues?
Yes. I don't know about the other ones, but in Matterport you do actually get the option to blur out. It does actually have an option to automatically blur out the faces.
Yeah, so if you were publishing it.
Yeah. You can also manually blur it if there's like computer screens that you want to cover the information on, or if someone's like slacking off at work and you don't want to snitch them out to their boss or something. But yeah, you can. Yeah, there's an AI tool for it, and then there's manual in case something gets missed.
Do the scans address MEP conditions as well? I know you talked a little bit about that.
Well, if it's an exposed ceiling, it would pick up all the pipes and stuff. So A lot of times, if you look up in warehouses, you can see a lot of the pipes, the ductwork that are exposed. But we don't go, like, if it has a suspended ceiling, we don't go removing the ceilings and scanning above the ceiling. We don't do that.
How do you budget compensation for a project? What were the costs of the project shown?
I can't really talk about the actual project for each one, but we typically look at the hours, and I have like a sense of how much I was charging for past projects. So for current project, we did similar. So we're actually able to make a little bit of profit, extra profit on it. Not in the beginning though. In the beginning, he took forever to do the job. So
The price of learning.
yeah, price of learning, right? But the learning curve is like I said, we just had one staff just join, no experience doing SketchUp within because I think they're Gen Z, right? They're able to jump on SketchUp, fly around SketchUp within a matter of like an hour. And then next thing you know, we show them how to work with the cloud tool, right? Next thing you know, they're drafting out those plans, within a couple of days, we're running full speed, right? Yeah.
Any possibility in the future that scan files can be transferred into AutoCAD directly rather than converting into Revit and SketchUp first?
Well, AutoCAD doesn't have like 3D AutoCAD, I guess, could do it, but I mean, Revit is a 3D software, so it's able to hold 3D information. So it's SketchUp, so it's naturally, it's natural that it's able to do that. Now, what would be fantastic is if an AI software came in and said, okay, made some of those decisions for you on how to draft out a wall, like it would drive me crazy if the AI took a wall that was off 1/16 of an inch, off plumb, and it drew that wall 1/16 of an inch. Because if I go to offset that wall to draft out another line, all those walls are going to be off in a skewed angle instead of the intent is to be parallel, right? Sometimes like you want things there's the design intent and there's reality, right? If you show too much reality, yeah, it's going to mess up your design intent, right?
Did you look at renting a scanner before deciding to buy one?
There's actually services, people who have scanner that would you could hire them to do the scan for you. If you wanted to, set up an account, you could have them scan it and then give you the cloud file if you want to do it yourself and give it a shot. So there's services out there. Not all areas have it, but usually in urban areas, there's people with scanners that would go out and you could hire them just to do the scan for you. But they talked about doing rentals too. I think there was one company that in New Jersey that allows you to rent it, but I really honestly never looked into it. I looked at the price of it. As I said, it was advertised around $8,000. They had a holiday special towards the end of the year. It's coming up pretty soon, so they dropped it to somewhere around like $6,500. And at that point, I kind of looked at it and said, look, if this really does, what it's supposed to do, the amount of work that we do out of our office, like I said, so far since January, we did 26 projects. It more than paid for itself.
Yeah, I know now actually recently Matterport does, you can rent directly from them. And they'll send you everything to try it out. I had another firm I know that just did that last week and it convinced them to buy it. So it's exactly what we're trying to do.
I talked to other architects before I bought it. There was a firm in California, and there's a firm, I forget the one gentleman, but we architects are awesome because you ask, if you want to, there's the one architect that I talked to, he gave me so much insight, and he says if you ever want to more pointers or stuff, that give him a call. I spent probably an hour with him talking about the ins and outs, because I've physically done a lot of field survey work myself, so I was able to ask a lot of technical questions. And he answered all those questions. And certainly if anybody has questions, I'd be willing to, spend some time, answering their questions, I'm on the board, so you can find my contact info pretty easily.
Do you need a high-end graphics card to navigate the point cloud?
I mean, all our computers have Pentium 7 or better chip. The graphic cards, I think we have a regular gaming workstation. We didn't get any extra souped up graphics cards, and it works pretty good. The one that Zach worked on, that the station that we had the SketchUp on, that one has a pretty robust. It's got the NVIDIA GeForce graphics card. I forget which one, but it's not. It's like something that you would find in a reasonably priced gaming computer. That this workstation computer costs like, I don't know, like $1,500. So it's nothing crazy.
One of other questions.
Mm-hmm.
Yeah, there was another question about roofs, and I'm imagining meaning more of actual residential, sloped roofs than flat roofs.
We didn't scan like the roof. I talked to my consultant who does a lot of as-built drawing. I asked him how he handles the slope roofs. A lot of times he has enough profiles, from the interior scans and then the exterior scans. And in the old days, like he would extrapolate like the roof shape based on the photographs of the exterior. There's actually an online service right now. A lot of the contractors are using. If you take your iPhone, go around the house, take pictures of it, it would actually make a 3D model pretty accurate to the half inch, they say, and it's able to generate all the profiles of the roof and the exterior elevations, and they do it for a very nominal fee. So if you look up, I forget off the top of my head what service that is.
Hover something.
Yeah.
I used it quite a long time ago. I got it from a contractor. Same thing. They use it for like, doing material takeoffs for estimates and stuff. But it's I don't think they use the 3D model aspect of it, but it's there too.
Yeah, I went on their website and saw that they're able to generate pretty accurate, elevations, and off of that they could extrapolate roof plans too.
Yeah, and I think they can even do. I know I saw where they have in the app, it'll create like a 3D model right there in the app for you, and you can change. If you want to see blue siding instead of green, you can kind of manipulate it even just right there from the app. That's got some cool things, but it's not definitely a different thing than a 3D scan.
Yeah, if we're talking like just strictly using the scanner to get those roofs, it's probably pretty hard unless you're getting direct, if you can get onto the roof.
Yeah, if you could walk a roof and scan it. But I mean, when we did hand survey measurement, we just took photographs and tried to get the approximate pitch, right? And get the approximate measurements based on that. It was always approximated, right? It was never like 100% accurate. And, when you tell the contractor to match our roof pitch, you say match our roof pitch, right? Or match that eave height, One thing that I would say that I talked to the firm in California that incorporated Matterport for several years. They actually created a small division to do as-built for other architects. It's something that we talked about. Maybe eventually we'll do something like that. But I think it's another income stream for architects, because if you get good at it, and you being an architect, I think you know what to look out for and how to draft out floor plans that make sense. Like I said, I had as-built guys who didn't know that if you have floors, it's got to stack, right? The stair walls got to line up, right? Those kind of things. You know, there's a lot of guys that don't know that. And I find it frustrating, you know, working with as-built companies, you know, especially if you pay a couple grand for it, right? And things don't line up, you know. I had to work through several as-built companies before I found guys who could do that right, you know. But as architects, I mean, you could consider this a really good, viable income stream, you know.
Great. Well, I think that's the end of our list of questions. Oh, you're muted, Lisa.
So thank you to Ben and Zach. It was a great presentation. And to those of you out there listening, if you enjoyed this, you should join our small firm exchange committee. This idea for this presentation, I think, came out of a discussion at one of our monthly meetings or bi-monthly meetings where we didn't have a speaker and we just were throwing out ideas. And I think I had said that I still do all my measuring by hand with a tape measure by myself. And I was kind of interested in learning about some of the new technologies. And Ben said he had, you know, recently bought the scanner and was willing to come talk to everybody. So it's a great forum for, you know, finding out about different things. And so please join us. You can contact either Christina Goldstein, our events planner, or any one of us, and we'll put you in touch if you didn't catch her contact information, although it's in the chat right now. So thank you, everybody, and good night.
Thanks, guys.
Bye, everyone.
Thanks.